Hello guys, so this is a continuation of our topic on net tensile strain determination. So we now go over the ACI provisions on compression control and tension control sections. Okay, so this ACI provisions actually started way back in 1999 on alternate provisions, and then for the regular provisions has started ACI 2002 onwards. Okay, so for a unified uh, analysis on both axial and axial flexural members, or simply columns and beams, we may consider this compression control and tension control, especially when we're dealing with the ductility considerations. Okay. So what's a compression control section according to ACI? These sections are said to be compression controlled when the net tensile strain in the extreme tension still is equal to or less than compression controlled strain limit. So we are now defining a limit on the tensile strain at the time the concrete reaches its ultimate brushing strain of 0.002. So basically the idea is still to allow steel to yield prior to crushing. Okay, so if we want ductility to happen, epsilon Cu, which is equivalent to 0.002, must always be considered as your ultimate crushing strain prior or after, rather, after the steel strain has been reached in order for ductility behavior to happen. Okay, so what's this compression control limit? So the compression control strain limit is the net tensile strain, the reinforcement at the balance condition. So this is the raw balance parameter that we've been using in the older codes. Um, but now it was just converted into a strain limitation. Okay, and for grade 60 reinforcement, this is equivalent to 0.002. So this is simply a ratio of your Fy and your modulus of elasticity. Okay, so for a grade 60, this is approximately 0.002 something. And this is the basis for your uh, compression control limit. So perhaps I have shown you this limit in my discussion on how to determine the net tensile strain. So this is the limit, which is equivalent to 0.00. Okay, so for the tension control section, so ACI 10.3.4, sections are tension controlled when the net tensile strain in the extreme tension still is equal to or greater than 0.005. So you will be noticing that we are actually increasing the net tensile strain, while in the old codes we are decreasing your reinforcement ratio uh, into a smaller value for us to make ductility achievable. Okay, so here decreasing strain, but while in here with the limit for tension control, we are actually increasing the strain. So when raw is reduced, then we are actually achieving ductility. Okay, when epsilon t is increased, we are actually achieving ductility. So they are actually inversely, okay, inversely proportional with each other, but they mean the same thing. We are simply talking about your steel area here, while here you are talking of the strain at that particular steel level. Okay, why 0.005? Because we need to have a factor of safety for us to ensure that the steel will yield first. So 0.005 is way far here than 0.002. Okay, so these gray areas I've discussed in my previous lecture will be taken care of by the reduction factor phi in terms of ductility. This is called the transition zone. So the transition between a compression control and a tension control section simply states that the, the member or the element is uh, what? Somehow behaving sometimes like a beam and sometimes like a column. No? We know that beams behave uh, in a more ductile fashion than columns because columns are compression members. Okay, so for and the non-pre-stressed flexural members and non-pre-stressed members with actual load less than 0.10, so we are now specifying a pure flexure case here. No? So this is a pure flexural behavior, almost, or simply beam behavior. Okay? Here we are assuming it to be an axial flexural or a beam column behavior. Here we are assuming a pure flexural behavior. The tension control limit was actually reduced somehow by a lower value at 0.004. Okay, so we can give some allowance because this is a ductile member because it's a beam. Now for an axial flexural member like a beam column or a column which is subjected to flexure, we need to ensure ductility, so our upper limit for tension control must be 0.005. So note that the objective of introducing concept net tensile strain is to provide unified design procedure that will be consistently applicable to the entire spectrum of flexural and axial flexural members, which includes columns, beams, and pre-stress and non-pre-stress members. So the compression control strain limit or the lower limit corresponds to the balance strain condition limit drawn in the previous codes. Okay, so we can actually make use of a derivation later on how to compare the strain limitation in terms of the uh, reinforcement ratio limitations. Okay, so we're familiar with this formula in general. Okay, so that's it for the two type of sections in the unified provision. I will be discussing to you more of this in the next video. Thank you very much for listening.